Chapter 16. Some Natural Phenomena. Introduction. Human beings live in the lap of Mother Nature. Our existence is a gift from her. We humans are constantly using the natural resources provided by her for our development. In doing so, we change the nature and its balance. Sometimes nature lashes back and then we realize how small and helpless we are against her power. Lightning. Lightning has existed in the universe since its formation. In ancient times, people thought that gods showed their anger through lightning. Today we know that lightning is nothing but electricity. In order to learn more about lightning, we need to first learn about static electricity and electric sparks. Static electricity.
According to historical accounts, the knowledge of electricity dates back to about 600 BCE, when a Greek mathematician, Thales, discovered that when amber is rubbed against animal fur, it attracts light objects. It was thought that he noticed the static electricity produced in amber on rubbing. In the early 18th century, many experiments were made in the field of electricity and static electric generators were developed. What exactly is static electricity? Let us do some activities to understand the nature of static electricity. The static charge in an object can be detected by a device called electroscopy. Let us make our own electroscope and see how it works. Can you think of a variation in this experiment to create attraction between the strips? In the above experiment, you touch the aluminium strips with hand after they repel each other, and they will come back to their original position. This is because the charge present in the strips transfers to the earth through your body. The strips are now said to be discharged. The process of transferring the charge from a charged object to the earth through conduction is called earthing. All electrical gadgets we use are provided with earthing to protect us from electrical shocks.
Why is static charge created?
We learned in the earlier chapters that matter is made up of very small particles called atoms. These atoms are neutral, but they contain yet smaller charged particles. The positive particles are called protons, and they are found in the central region of atoms called nucleus. The electrons are negative and are found around the nucleus. In some materials, electrons are tightly bound to the atoms, while in others, they are loosely bound. When we rub the surfaces of two objects, the electrons may get transferred from one surface to the other. When we rub surfaces of two objects, the loosely bound electrons are transferred to the other object. As a result, the object that loses electrons becomes positively charged, and the object that gains the electrons becomes negatively charged. These charges are called static charges. So, when you rub a balloon with woolen cloth, electrons transfer from the wool to the balloon. Hence, wool becomes positively charged and balloon becomes negatively charged. Static electricity can be created in the following ways. By rubbing the surfaces of two objects so that one becomes positive and the other negative. By touching an object to a charged body, the charge from the charged body will transfer to the object and both will have the same charge. By bringing a charged body near a neutral object but not touching it. The neutral object is attracted to the charged body. This is the reason that paper pieces stick to the rubbed scale. The scale has a negative charge. When we bring it near the pieces of paper, the area of paper closer to the scale becomes positive and the paper sticks to the scale. This is also the reason behind the lightning strikes on earth.
Electric spark.
In winter, you must have seen electric sparks when you take off an acrylic sweater from your body. An electric spark is caused by two opposite charges between two objects. When two objects are rubbed, one becomes positively charged and the other negatively charged. If a lot of positive and negative charges accumulate over a small area near one another, they heat up the air between them. The air glows for a short time and makes sound. During this time, the air loses its insulating properties and allows one charge to flow to the other. This flowing of air with sound is what we call an electric spark. It lasts for a little while because two charges cancel out each other and become neutral as soon as they meet. Hence, an electric spark is the transfer of charge between two surfaces through air, which produces heat, light and sound.
Lighting is an electric spark on a very large scale.
Lightning.
You must have seen lightning during a storm. You must also have heard that during lightning, one should avoid moving out. Lightning is the bright flash of light that is seen in the clouds and is followed by a loud sound called thunder. Let us understand that lightning is nothing but a huge electric spark in the sky. During a storm, dark rain clouds move across the sky at high speed. The cloud contains water droplets and ice particles. As the cloud floats, strong winds move through it. This wind makes the water and ice particles rub against each other. The smaller particles get positively charged and move to the top of the cloud, while the heavier particles become negatively charged and move to the bottom of the cloud. When there is huge amount of both charges on opposite sides, the charge flows from one side to the other through the air. This creates a bright streak of light and intense heat. Due to intense heat, the surrounding air expands very quickly, making a loud sound. This is what we know as lightning. Sometimes the clouds move very low in the sky. When the negatively charged lower part of the cloud is close to an object, the object acquires high positive charge, and the charge floats from the cloud to the object. Through the object, the charge passes to the ground. This is what happens when we say lightning has struck. Usually, lightning strikes tall objects like trees, towers, chimneys, and poles on top of buildings. This is because the top of such an object is closer to the clouds. Lightning produces lot of heat and hence can burn the objects it strikes. However, if the object is a good conductor, the charge can pass to the ground. These days, buildings are fitted with lightning conductors. A lightning conductor is a metal rod that runs from the top of the building to the ground. It attracts the charge when lightning strikes and then passes it to the ground. The top of a lightning conductor is forked and is fixed at the highest point of a building. Lower end of it has a metal plate which is buried deep into the earth. The lightning conductor can save buildings from extensive damage in case lightning strikes. Lightning burns trees, can make the building weak,
damage electrical gadgets in a building, and kill people.
Protection from lightning.
Lightning is a natural phenomenon and cannot be stopped. However, we can minimize the damage from lightning by observing the following precautions. During thunderstorm, do not move in open spaces or in an open vehicle. You should rush to a shelter or be inside a building. In case you are in a vehicle, close the doors and windows. Do not take shelter under trees. If you must, stand under a short tree rather than a tall one. If you are in an open space without a shelter, stay away from the trees and poles. Do not keep an umbrella over your head. Switch off unnecessary electrical devices like television during a thunderstorm, as their antennae are generally on the roof of the building and can get struck.
Earthquakes.
We all experience an earthquake in our lifetime. It is that scary short time when the ground beneath our feet starts shaking, and so does everything around us. Earthquakes are those natural disasters which come without any warning and can cause huge damage to life and property. Let us learn what an earthquake is and how it is caused.
Structure of the earth.
Standing on the ground, you must think that the earth below your feet is solid and hard. It does not undergo change. However, this is not true. Our earth is made up of different layers which keep changing. The earth has a radius of about 6,375 km and it is divided into the following parts. Core. It is the central part of the earth, believed to be made up of mainly iron and nickel. The innermost part of the core is solid. The outer part of the core is liquid, which keeps moving. The movement of this core is believed to cause the magnetic field of the earth. Mantle. It is the thick layer above the core. It is made of dense and hot rocks. The inner part of the mantle is partly liquid and is called magma. When the magma comes out of the earth, it is called lava. Crust. It is the outermost layer of the earth on which we live. The crust is thicker on the continents, but thinner under the oceans. The crusts, along with the upper part of the mantle, are together called the lithosphere.
Movement of continents.
Crust is a thin layer on the surface of the earth. It is made up of different pieces called plates. These plates float slowly over the mantle like a raft moves on water. Note that the plates move very, very slowly, about 1 centimeter per year.
So, their movements are not detected.
Cause of earthquakes.
The moving plates of the Earth's crust slide past one another. As they come into contact with each other, there is friction between them, which may stop them from moving. Sometimes the rocks at the edges of two plates get locked. This leads to building up the forces. When the forces become very strong, the plates jerk past each other. This releases tremendous energy in the form of waves. These waves shake the crust and cause earthquakes. The place from where the vibrations originate is called the focus of the earthquake, and the point vertically above it on the surface of the earth is called the epicenter. The energy waves that originate from the focus are called seismic waves. When these waves reach the surface, they cause the surface to shake and crack. This may lead to sinking of ground and falling of all construction on the surface. The energy released by big earthquakes is tremendous. It is equivalent to energy produced by many atomic bombs. This is the reason earthquakes cause so much damage. Not all earthquakes are caused by colliding plates. Sometimes an earthquake is caused because of eruption of a volcano. A nuclear explosion carried underground can also cause an earthquake.
Measuring scale for earthquakes.
The scale on which the intensity of an earthquake is measured is called Richter scale. It was developed by a seismologist from the US, Charles Francis Richter, in 1935. On this scale, the intensity of an earthquake is measured from 0 to 9. Earthquakes till the magnitude 3 on the Richter scale are not felt by us. They happen very often but are not a cause of worry. Up to the magnitude of 5.5, an earthquake can move objects and sway buildings. At higher magnitude, the earthquakes becomes dangerous and can damage buildings and infrastructure. An earthquake of magnitude 8 or more can be very dangerous. It can wipe out entire cities.
Earthquakes of high magnitudes can deform the ground surface.
They can cause landslides and change the course of rivers. Sometimes they cause the oil and gas pipelines to rupture, which can cause huge fires. Sometimes earthquakes also cause tidal waves or tsunamis. An earthquake with focus in the ocean sends out waves at very high speed. When these waves reach near the shore, they slow down. As a result, they rise very high. A tsunami wave can go up to a height of 30 to 40 meters. These waves crash into the coastal areas and cause huge damage to life and property.
Earthquake-prone regions.
The regions which are near the plate boundaries are more prone to earthquakes. These are called seismic zones or fault zones. In India, Kashmir, Northeast region, Western and Central Himalayan region, Rajasthan, the Rann of Kutch and the Indo-Gangetic plains are the areas in the fault zone.
Protection against earthquakes.
We cannot predict earthquakes. However, it is possible to follow certain precautions to minimize the damage from them. Buildings should be protected against earthquakes. In highly dangerous zones, houses should be made of mud or timber rather than concrete. The roof should be made of light material. Cupboards and shelves should be posed to the walls so that they do not fall. There should be proper firefighting arrangement in the house. In the event of an earthquake, one should take shelter under a table, away from tall and heavy objects. If you are outside when the earthquake occurs, move away from buildings, trees or power lines.
Drop to the ground.